Okay, good morning everyone and happy Friday from the West Coast. My name is Erin. I'm the Business Development Manager over here at Softree, and today I've got the pleasure of introducing our free webinar topic, which is horizontal vertical curves. So thank you all for joining us. We do have a couple pieces of housekeeping. The first of which, you are all muted. That doesn't mean we don't want to hear from you, it just means we can't hear you. So to ask questions and engage with us throughout this presentation, there is a question section in your GoToWebinar panel. So all you need to do is go to that question section, expand it out, and you can type any questions throughout the presentation, and we will be addressing them. And then secondly, we are recording this webinar, as we usually do, and we will be making it available on our YouTube page. So that gives you the ability to watch it again and again if you're interested. What is today's webinar about? Well, we're going to be taking a much deeper look at horizontal and vertical curves. In most of our webinars, we seem to quickly go through these motions, but today really is about getting a much deeper look at the advanced mode of both our horizontal and vertical curve panels and taking a closer look at the elements that are within them, whether that's accessing superelevation tables, setting road class specifications, friction factors, widenings, curve transitions, and more. Jack, our applications engineer who's with me today, is going to be using a county road project based on LiDAR data. And this project is actually going to be have some rough alignment already done, so we can keep it relatively concise. And I think with that, I'm going to pass it right over to Jack, and he's going to jump into the software, into our RoadEng program, and start giving us a deeper look at curves.
Good morning, folks. Thank you, Erin. Let's just get started. As Erin said, this is just a simple two-lane county road on LiDAR data. The horizontal IPs and the vertical IPs have already been entered into the for the alignment. As you can see, there's a lot of horizontal, and if I go to the vertical window, there's some vertical IPs also. But I haven't put any curves in yet because I'm going to do that now. I'm going to retrieve a screen layout that sets up my screen for horizontal alignment first. And it has a horizontal curve panel, which is over here over the right. It has a plan window, a section window, and a horizontal curve panel. First things first, let's just use these buttons here to jump to next IP, because that's where you have to actually put in your horizontal curves. I'm going to jump one IP. You can see my crosshairs are now at this point right here. Show you how to set up a default curve. Click on circle. I'll talk about spirals later on. To set up a default, what I'm going to do is I'm going to use this. I got design speed here. I've got radius. This is a metric design, although you can do the same thing in imperial units. Everything here is based on TAC tables because it is in metric. Up here in Canada, we have TAC tables. Down in the United States, they have AASHTO tables. We have both tables built into our software, but since this is a metric design, we're going to be using the TAC tables. I'll talk a little bit more about TAC tables in a bit. I just want to set up a default first. I'm going to have a 70 kilometer per hour road. You can see that as I change the radius from 80 kilometers to 70 kilometers per hour, the radius changes to 190. Now, how does it know that the radius should be 190? And when it was 80, it said it was 250. Let me just go back to 70 and just investigate this a little bit more. If we look at the, if we click on this plus sign right over here, and we look at the table, the TAC table that's built in, you can see that atop the top row is your design speeds, and the first column is your radius. If we go down all the way down to the 70 column, see down at the bottom, there is a number at the bottom that is the last number here, 190. So the software just looks right at to the bottom of the whole column and just looks for the minimum radius that's allowed for that design speed. Similarly, for 80 kilometers per hour, the bottom number is 250. As you saw before when I changed the design speed to 250. And at this 70 kilometer per hour design speed, we have 8.06 or 6% superelevation. Let's just try a few numbers here. You can see that if I change my design speed, let's just go over 1 to 60. The bottom line is 130. So when I change it to 160, it should. When I change it to 60, it should actually say 130. Let me just do that. And yes, it does say 130. Let's just go back to 70. Like I said, the minimum radius at 70 and 190 is 6%, and that you got that from that lookup table. Again, the software just went across to 70, down to bottom line of 190, which is right there, and it gave me a 6% super. Turn this off and just talk a little bit more about superelevation and just see what happens if I change my radius. My minimum, I already know my minimum radius for a 70 kilometer per hour road is 190. So if I up that to 250, you'll see that it give me a 5.5% super. So I could set my minimum radius and then just turn that off and just up that a little bit more, just because I want to add a little bit more factor of safety in there. So I will post my design speed on this road at 70 and then probably design it for 250, just to give it a little bit more safety. Turn back on my minimum radius. Again, my superelevation changes back to 6%. Like Aaron said, I'm going to keep this demonstration to about half an hour. So we got a lot of things to talk about. Let's talk a little bit more about this number right down here, the side friction. The higher this number, the more likelihood that the car will skid off the road. So the lower the number, the more likelihood the car will have to stay on the road. Let's just play around with that. If we turn off our use minimum radius, and if we decrease the superelevation, watch what happens to this number. So at a lower superelevation, you should actually have a higher side friction. What that tells me is as the superelevation goes down, the likelihood that the car will skid off the road is higher. Similarly, if I change my superelevation back to 6% and change my radius to a larger radius, let's say 300, the likelihood that the car will stay on the road at 6% superelevation is much less than it was if I kept my defaults. So it's quite high. It won't skid off the road. Side friction is going to keep the car on the pavement. Let's talk about this number right here. If I turn on my use minimum radius again, this number is the transition length from full super to no super. If I look at where that number comes from, it comes from another lookup table. Again, similar to the lookup table that we had before, we go to the design speed across the first row on the top, and then the first column is the radius. So if we go down all the way at the bottom of 70 and the intersection of 70 and 190, we should see a 40, and yes, we do. So that's how that number came to be in this area right here. So we know that the transition is 40 meters from no super to full super. How do we know where that transition is occurring? Well, that's this number right here. Normally for county roads, the transition is 0.667. What that indicates is that 2/3 of the transition from zero super to full super occurs outside of the curve, and 1/3 occurs inside the curve. So 0.667 occurs outside of the curve, and 1/3 occurs inside the curve. Just take a look at that number again. Yeah, there it is, 70. I was looking at the wrong column. So it's 70 meter transition. Take a little bit closer at this look at this transition. You can see that we're at full super at the actual end of curve label and the beginning of curve label. Let's just go to the beginning of curve and just see all the transitions that occur. Right now we're at full 2% crown. If I go forward, you can see that that number starts to go down. One side starts to go up towards 0. And then at some point it is also flat on one side. And it's still at negative 2% crown on the other side. What this is called, from crown to this point, it's the superelevation runout. From here to this point right here, we're still in runout. We're actually going from superelevation runoff to runout to through the superelevation runout, and then coming to full super right here. So no, sorry, we're at the 2/3 point here, because like I said, 2/3 of the transition occurs outside the curve. So if I go back, this is where we're at full. So this distance right here from this little green dash to the begin curve is the 1/3 distance that we needed to get to full super. So we're now at full super, and we maintain full super throughout the length of the curve until we get to the 1/3 point, where this distance is 1/3 from the EC label. So if I go forward until I hit the EC label, now we'll be at the 2/3 point again. And then we finally hit the transition tangent runout, superelevation runout. Let me talk about spiral curves a little bit later. I'm just going to assign this, set this as my default curve, and then jump, get my default, and apply. You can see that it gives you the percentage for the tangent runout. We do have a widening portion to our curve table. So if you want to make your curve a little bit wider on the inside, outside, or both, you can put in extra widening. And if I decide to do that, the software will automatically use this transition length as well as the transition fraction to give me this transition also of 2 meters, 0 to 2 meters widening. So you can widen, like I said, on both the inside, outside, or both. Let me just turn that back to 0 and add a few more of these curves until I get to a point where I want to talk about spiral curves. I think this is a good point to maybe put in a spiral curve. Spirals are a little bit different than circular curves. The actual transition occurs throughout the entire curve. So the actual tangent transition length is from the beginning of spiral to tangent, curve to spiral, and then from curve to spiral to curve, and then tangent to spiral. That length of transition occurs within these two labels right here and these two labels right here. Okay, I'm going to go back to a circular curve. Set that as my default again. I'll show you how to add in. You can only have, by the way, you can only have one default at a time. You can't have multiple defaults. So if you want to have multiple defaults, you're going to have to change the default either halfway or keep on changing it as your design speed changes. I'm just going to keep this default. Jump, get default, apply. Jump, get default, apply. Get default, apply. Jump, get default, apply. I've got a few more only. I'm just going to finish them all off. And then I'll talk about this area right down here. This is the road class specifications dialog box. You can set up, so this is just a simple 2-lane county road. Set up the minimum design speed. Put in your reaction time, your eye height of your driver's eye height. In this case, it's 1.08 meters. You set these all up yourself. Minimum radius. For vertical curves, you have to give it a minimum sag, minimum crest. Maximum grade, minimum grade, maximum super elevation. So these numbers you just put in yourself, you type in yourself. Oh, by the way, just as I'm here, these tables, these TAC tables and AASHTO tables, if you're in the United States or in Canada, if you have different state tables, you can create your own. All they are is just simple text tables that you can create, or different provincial tables. You just modify the actual text table and then save it and open it up into your own horizontal curve window. Just a few more curves left. And that's it. That's all there is to know about horizontal curves. Let me get another screen layout for vertical curves. And we'll talk a little bit about vertical curves. Let me just jump back, all the way back to the beginning. The second IP. I can get a default again. My default is set based on what I set up in my horizontal curve, so 70 km/h road. And it's automatically calculating a K value. Now the units for K in this case are meters per percent. So what the software does is it takes the distance here, which is 94.820, and we can see that we have a grade. If you look over here, you can see it in the curve panel. We have a grade before and a grade after, negative 3.7% and 1.4%. So what the software does is take negative 3.7% and subtract from it 1.4%. So that means that would give me a negative 5.1%. So negative 3.7 minus 1.4, you get this number right here, which is negative 5.1. Divide that into 94.820 and you get 18.65, sorry. K value, so that's the parabolic rate of change for a vertical curve. Vertical curves are different than horizontal curves. Horizontal curves are radius. Vertical curves are parabolas. So if I decide to change my design speed to 80, you can see that the all things being the same, the K value, the length will change. The length will change because the grade the grade has stayed the same. The length will change, the K value will change. Let me just put my 70 back. Apply. Now if I decide to move this up and down, you can see that the length is changing and the K value is changing. That's because both the grade and the length are both changing at the same time, giving me different K values all the way up and down as I move up and down. Now if you want to, you can set up your own K value or length just by turning off the auto. I know that my minimum K value is 18.52 at this position right here for 70 kilometer per hour road. I can up that to 20, for instance, giving me a length that's longer than 94 point. If I turn back auto, that was 88.0. Let me go back to 20. It's going to give me a 95.057% length. So I can up that to make it a safer road if I want to. Some people do not think in terms of K. Some people think in terms of length. So for instance, they want to have I've had this a number of instances where people have wanted to have a minimum 100 length curve, and based on this design, a minimum 100 length curve will give me a 21.04K. Let me just turn that back on, apply. You can also, this number right here is the site stopping distance. The minimum site stopping distance for a vertical curve of 70 kilometers per hour at this position right here is 110.376. That is the minimum. You can turn that auto off and then just up it to 120 if you want to give it a little bit more safety there. Okay. Let's just set this as my default curve. Jump forward, get my default curve, apply. Just going to do this a couple more times. If you can't fit your default, let me just show you one thing. Let me just go back and put no curve, apply. I'm going to make this a lot steeper. And then try to get, well, let's just make it a lot more steeper. You can see that you get this warning sign. It does not let you put in that curve because you cannot overlap two curves. This is the same kind of warning sign you would get in the horizontal window. I didn't show you that just because it slipped my mind. But you will get this warning sign. You cannot have overlapping curves. You cannot have a curve that overlaps over an existing IP or PI. Just be aware of that. If you do get this error, you just have to move the IP away from the other curve or the other IP and then try to fit your curve. I'm going to just put in 3 curves for today. You can move your curve around after you've got it to where you want, and then you can have them touch if you want to. Again, just to reiterate, if your IPs are too close, you might not be able to get this error message. Just move the IPs away from each other and then try to fit the curve. And then if you want your curves to be back-to-back curves, you can just move it back until they touch, until the begin curve of one curve and the end curve label of the other curve touch each other. Well, that's it for today, folks. Thank you very much for your time. I think I'm going to hand it back to Erin.
Great. Thanks, Jack. Introduce the upcoming webinars that you're welcome to sign up for. We've got earthwork balancing, earthwork optimization, I should say, beyond balancing, resource road design coming up the beginning of April, RoadEng with Civil 3D and En-ROADS. So we're going to be taking a look at our compatibility and how we interface with those two programs, April 15th. And then for those of you who haven't seen it yet, an introduction to Softtree Optimal, and that is our vertical alignment software coming up on Friday, April 29th. I think that's it for the webinar. So I just wanted to thank everyone again for your time, for the date change. I know we had to move this webinar from last week, so thank you very much for making adjustments in your schedule and for joining us today.